Assalamualaikum warahmatullahi wabarakatuh and hi to everyone. In this video, we will present about assignment 1 network TST3233. First of all, let's meet your presenter. The first one is Azizatul, which is myself, and the second one is Satya Ruben, which is my classmate. There are two sections in this video, which is section A and section B. I will explain about section A, while Satya will explain about section B. Now, let me explain about section A first. The first topic is how to prepare the data format. A data format is the arrangement of data field for a specific shape. After you arrange the data field on a shape, you can save the data format as default or custom. First, you have to access the data. Second, you have to fetch the data. Third, you have to cleanse the data. Next, you have to format the data. Then, you have to combine the data. And lastly, you have to analyze the data. The second topic is how data being divided. The process of dividing a data packet into smaller units of transmission over the network. The transport layer of the OSI model is where packet segmentation takes place. When a data packet is larger than the network's maximum transmission unit, segmentation may be necessary. Now, let's move to the third topic, which is header for each layer. Each layer has its own header, containing information relevant to its role. This header is passed down to the layer below, which is in turn its own header, until eventually the physical layer adds the layer 2 information for passage to the next device, which understands the layer 2 information and can then strip each of the layer's header in turn to get at the data in the right location. Each layer within an end station communicates at the same layer within another end station. Now, let's see how header being added to each data. The process of adding headers for each data is referred to as encapsulation. To the data provided by the upper layer, each layer adds its own header. The transmitted data is then received by the transport layer from the upper layers. It divides the data stream received into smaller pieces. Segmentation is the term for this procedure. It constructs a header for each data piece after segmentation and connect that header to the data piece. Next, let's learn about segment. Firstly, let me explain about what is segment. A segment is a broken piece of a packet with a TCP header in each of them. Segment increase the efficiency of network performance and improve security. Segments are in a transport layer. Let's see the example of segment. Another example of segmentation is when you are downloading something from a server. Let us suppose that computer A is downloading a video from the server B. In this situation, computer A is the receiver on the grounds that data flows from the server toward the computer. After the video downloading reaches 90%, an error occurs and subsequently the download stops. If the video is not segment, it will fully be lost. But if it is segment, the user can resume downloading because there are some already received segment. The next point is frame. Let's see what is frame. Frame is a digital data transmission unit in computer networking and a basic container for a single network packet in packet switching system. In other telecommunication system, a frame is a data that is transmitted between network point as a unit complete with addressing and necessary protocol control information. The 7th point is sequence. In this slide, I will show what is sequence and the relate of sequence to our everyday life. Definition: sequence are the main logical structure of algorithm or programs. When creating algorithm or programs, the instructions are present in a specific correct order. A sequence can contain any number of instructions, but each instruction must be run in the order they are present. No instruction can be skipped. For example, we can relate sequence to our everyday life. Think about making a PB&J sandwich as a task. For example, if we want to make a delicious peanut butter and jelly sandwich, we need to follow multiple steps in a logical order. We should begin by gathering our ingredients, getting a knife, spreading the peanut butter, spreading the jelly, and so forth. Next point is address route. What is address route? Address route is a technique in which a routing decision is made by looking at the source address of a packet in addition to its destination address. The address tells the computer in the internet where something is topologically. In the next slide, I will talk about MAC address. Firstly, let's see what is MAC address. A media control address, or known as MAC address, is a unique identifier assigned to a network interface controller (NIC) for use as a network address in communication within a network segment. This use is common in most IEEE 802 networking technologies including Ethernet, Wi-Fi, and Bluetooth. Now, let's see how MAC address is formed. MAC addresses are formed according to the principle of two numbering space based on Extended Unique Identifier (EUI) managed by the Institute of Electrical and Electronic Engineers IEEE EUI 48, which replaced the obsolete terms MAC 48 and EUI 64. The 10th point is IP address. The Internet Protocol address, or known as IP address, is a numerical identifier that is connected with a certain computer or computer network. The IP address allows computers to communicate and receive information when they are linked to the Internet. There are two elements of IP address. The first is the network ID, which is made up of the first three numbers in the address. The second is the host ID, which is the fourth number. Now, let's talk about a packet forwarding. In this slide, I will explain about what is packet forwarding and how the packet forward. Firstly, let's see what is packet forwarding. Packet forwarding is the process of a networking component accepting a packet and transmitting it to its destination. For example, a router receives packet from host on one attached network and forward them to host on another attached network or to another router for further forwarding. Now, let's see how the packet forward. Based on a comparison of the packet's destination address with the routing table stored in the router, each act of forwarding performed by a router is called a hop across the internet network. The 12th point is error control related. Error control is basically a process in the data link layer of a process of detecting and correcting frames that have been corrupted or lost during transmission. Because communication routes may be very unstable in many cases, good error control ensures that send and receive data are identical. The next point is handshake protocol involved. The handshake process set up automated parameters for communication between devices before normal communication begins. Much like the way a human handshake set the stage for the communication to follow, the computing handshake provides device with rules for the way the data is to be shared between them. This rule can include transfer rate, coding alphabet, parity, interrupt procedure, and more. Now, let's see how handshaking is used. In order to establish a connection between a computer and a device like a modem, printer, or server, the handshake process begins the connection by telling the device how to communicate with each other. A classic example is the noises made when two dial-up modems connect to each other. That squealing noise is actually the handshaking procedure. A handshake can also be used between a computer and a printer before printing takes place to tell the printer how to receive and output the data it received from the computer. Now, let's see about TCP and IP. TCP stands for Transmission Control Protocol, while IP stands for Internet Protocol. It is a set of protocols, standard, and procedure for interconnection network device on the Internet. TCP and IP are two separate computer network protocols. The IP part is responsible for obtaining the address to which data is transmitted, while TCP is responsible for data delivery once the IP address has been found. Next, I will explain about UDP, which stands for User Datagram Protocol. User Datagram Protocol is a communication protocol that is primarily used to establish low latency and loss tolerating connection between applications on the Internet. UDP speeds up transmission by enabling the transfer of data before an agreement is provided by the receiving party. Now, let's see the UDP feature. User Datagram Protocol has attributes that makes it beneficial for use with applications that can tolerate lost data. Below are some examples. It allows packets to be dropped and received in a different order than they were transmitted, making it suitable for real-time application where latency might be a concern. It can be used for transaction-based protocol such as DNS or Network Time Protocol (NTP). It can be used where a large number of clients are connected and where real-time error correction isn't necessary, such as gaming, voice, or video conferencing and streaming media. In this slide, you can know how UDP works. UDP uses IP to get a datagram from one computer to another. UDP works by gathering data in a UDP packet and adding its own header information to the packet. This data consists of the source and destination port on which to communicate, the packet length, and a checksum. After UDP packets are encapsulated in an IP packet, they are sent off to their destination. Unlike TCP, UDP doesn't guarantee the packets will get to the right destination. This means UDP doesn't connect to the receiving computer directly, which TCP does. Rather, it sends the data out and release on the device in between the sending and receiving computer to correctly get the data where it's supposed to go. UDP uses a simple transmission modem that doesn't include handshaking dialogues to provide reliability, ordering, or data integrity. Consequently, UDP service is unreliable. Packet may arrive out of order, appear to have duplicate, or disappearing without warning. Although this transmission method doesn't guarantee that the data being sent will reach its destination, it does have low overhead and is popular for service that don't absolutely have to work the first time. Most applications wait for any replies they expect to receive as a result of packets sent using UDP. If an application doesn't receive a reply within a certain time frame, the application sends the packet again or it stops trying. Next point is routing. What is routing? Routing is the process of choosing a path for traffic inside a network, as well as between and across network. Routing occurs in a wide range of networks, including circuit switch network, like the public switch telephone network (PSTN), and computer networks like the internet. Next, let's see about subnet. In this slide, I will explain about definition, example, and conclusion for subnet. Definition: a subnet or subnetwork is a network inside a network. Subnet make network more efficient. Through subnetting, network traffic can travel a shorter distance without passing through unnecessary router to reach its destination. For example, Alice put a letter in a mail that is addressed to Bob, who lives in the town right next to her. For the letter to reach Bob as quickly as possible, it should be delivered right from Alice's post office to the post office in Bob's town, and then to Bob. If the letter is first sent to a post office hundreds of miles away, Alice's letter could take a lot longer to reach Bob. For conclusion, like the postal service, networks are more efficient when messages travel as directly as possible. When a network receives data packets from another network, it will sort and route those packets by subnet so that the packets do not take an inefficient route to their destination. Next, let's see what is subnet address. Subnet address is a process that allows an autonomous system made up of multiple networks to share the same internet address. The subnet address is identified by all 0 bits in the host part of the address. The first host within the subnet is identified by all zeros and a 1. The last host is identified by all ones and a 0. The broadcast address is the all ones. Next point is how the data travel in binary. Transferring data through a cable uses the same principle as conducting electricity along a length of metal wire. At its most simplistic, data sent over a cable is converted into binary code, which is a collection of 1 and 0. The device transmitting the data will send current along the cable at 2 different voltages, for instance 0 volt and 5 volt, with one voltage representing 1 and the other zeros. The device receiving the data will interpret that current as binary code and then convert that back into the original format the data was before it was sent. The volume and speed of processing data over a specific time frame is covered by the Ethernet standards. The next topic is cable that the data will travel in binary. The same process of transporting electricity through a length of metal wire is used to transfer data via a cable. Data carried through a wire is translated into binary code, which is a collection of 1 and 0. At its most basic level, the device receiving the data will interpret the current as binary code, which it will then convert back to the data's original format. The volume and speed of processing data over a specific time frame is covered by the Ethernet standard. Next topic is network topology. Network topology refers to how various nodes, devices, and connections on your network are physically or logically arranged in relation to each other. Think of your network as a city and the topology as the roadmap. Just as there are many ways to arrange and maintain a city, such as making sure the avenues and boulevards can facilitate passage between the parts of town getting the most traffic, there are several ways to arrange a network. Each has advantage and disadvantage, and depending on the needs of your company, certain arrangement can give you a greater degree of connection and security. There are two approaches to network topology. The first one is physical network topology. It is referred to the physical connection and interconnection between nodes and the network, the wire, cable, and so forth. Second is logical network topology. It's referred to the conceptual understanding of how and why the network is arranged the way it is and how data move through it.
I am Satya Ruben. Now I explain how the message being sent from node A that located at National Defence University of Malaysia to node B located at University Malaysia Sabah using 7 OS layers. The application layer in an OS model is responsible for create a spread email by using simple mail transfer protocol. The application layer create a header encapsulation field with data like screen size and typefaces and deliver it to the presentation layer. Next, the header information is placed in the presentation layer. The message of the text is converted to the ASCII format. The new data will be sent to the section layer by the presentation layer. The section layer create a new end section for communication between devices. Then it regulates data flow within the section and send data revived from the preceding layer to the transport layer. In transport layer, the revised data is split down into parts and sent to the network layer. For example, it forming data segment. Adding source port is 16 bits and destination port 16 bits in header of the each transport layer, so total 32 bits. Next is network layer. It stores the source and destination address so a network is formed. It converts the segment receiver into packets. Data link layer take packets from network layer and the packet is converted into frames. Then the data is sent to physical layer. At the sender side, the physical layer will get the data of the frame, convert into bit stream, and eventually the data is reached to the receiver. The physical layer revises data from the sender, which is bit stream, is converted to the frame and passes to data link layer. Then the data link layer match all the frames information and makes those into packet, then send to network layer. In network layer, the packets are converted to the segments and pushed forward to the transportation layer. Then the transport layer each segment from source port and destination port that were received and joined into single data piece. In section layer, the single data element retrieved from the transportation layer is kept and flowed in the accordance with the section's communication. The presentation layer eliminates any necessary data comparison and transfer the newly accurate data to the application layer. Lastly, the application layer will display the readable data to the receiver, and the email will be successfully delivered and received.